Let's look at example number 1. Determine these indefinite integrals. That is, find the antiderivative of each integrand. So, the first one, if you're thinking, you're saying derivative of something is equal to 8. We're trying to think of what that something is. Well, derivative of 8x is equal to 8, isn't it? So the answer is simply 8x, but it can have a constant. So what we can say is the antiderivative is 8x plus c. You have to put the plus c there because if I ask you to find the derivative of 8x plus 5, wouldn't that be 8? Doesn't matter what number you add or subtract. If it's just a constant, that's going to be 0. So you have to still put that constant of integration. So if you just simply say 8x, that's incorrect. You have to be a little more specific and tell us that any constant can be added or be subtracted from that 8x and still have an antiderivative of, the derivative of 8. Okay, so that's it for that problem. Let's keep on going. Example, how about what kind of function or what kind of polynomial has a derivative of 3x squared? We can use the power rule. So we can increase the exponent by 1. So write down 3x, but write the new exponent of 3, go up 1. And divide the whole term by that new exponent of 3. That's it. And don't forget to put the plus c. We can simplify this though. 3 divided by 3 will just give us 1. So the answer is x cubed plus c. And for a check, you can quickly take the derivative of this. If you take the derivative of x cubed plus c, okay, x cubed plus c, wouldn't that be 3x squared? So what I just wrote down over here, this is the check. Okay, all right. How about next one? What kind of term has a derivative of e to the x? Remember, derivative of e to the x is equal to e to the x. So this is just going to be e to the x, but don't forget to put plus c. That's it for c. And the last one is a little bit tricky. Now for that one, we have to use the rule, the natural logarithmic rule, okay? So I want you to go ahead and highlight this. This part right here. The antiderivative of 1 over x is equal to natural log of absolute value of x. Because, this is going to be fun. Remember when we found the derivative of natural log of x, that was equal to 1 over x, right? But I think you may be wondering, where did this... Well, how come if you go backward? Because, we're trying to go backward this time. And you're probably wondering, where did you get this absolute value from, right? Because it didn't happen one direction. How come when we're going backward are we putting this absolute value around x? Well, because if you think about it, what is the domain of this 1 over x? If I say, if I say integral of 1 over x dx is equal to just this much, okay? The domain of 1 over x is all real numbers except for x equals 0. That makes sense, right? X can be any number. It can be positive, it can be negative. All of that, right? But what if you look at this guy? Domain of natural log of x, remember from pre-calculus, domain of natural log of x is x has to be greater than 0. all right? The argument has to be greater than 0. You see there's a domain mismatch, right? To solve that problem, that's why we put bar around this x. So x can be negative, but we will take the positive of that negative number because absolute value just makes everything positive, right? So that's why we put the absolute value around the argument x. But because of that, using that property, we know that the derivative of, the integral of 1 over x is equal to natural log of absolute value of x. And don't you forget to put that plus c after it, plus c. And that is it for this problem. And I tried to explain a little bit why we have to have the absolute value bar. I hope that was helpful, but I'm going to go ahead and put this example video on Canvas for you now.